it comes to Arduino, microSD cards, and battery power, you got to make sure you pick the microSD card that has enough storage space, but at the same time, you got to make sure it has a good sleep current on it. The lower the better. This way your device will actually run longer. Like my Arduino environmental monitor that I'm working on. So what we got set up for today is 10 microSD cards from 128 megabytes up to 16 gigabytes. For my device right now, I probably only need 128 to 512 megabytes for a year's worth of storage, the way I'm data logging right now. So, general convention says the smaller the card is, the less sleep current it will have. We're going to test that today. We got a multimeter set up. We're using Dave Jones, Mr. Aussie himself, his U-Current Gold, hooked into a microSD breakout board, and we're going to test each one and see what it does. Now, before we actually test all these cards, I ran them through my Android phone using an app called SD Insight. Apparently I have a microSD card in there right now. Oh wait, no, that's the built-in card, I think. Yeah, okay, it pulled up the internal card, no external card, the SDIO. But this will give you basically all the information on a card, and I put this into a little database, as you can see here on the screen. And it basically has all the information that's displayed by here. Okay, so let's get started. Got my anti-static strap on because it is the middle of winter. I don't feel like frying these cards. So, card number 1 is a SanDisk 128 megabyte card. So, put this in here. Meter is set up in voltage range. Let's turn the microcurrent on. Okay, it's stabilized. And we're currently set for 1 millivolt equals 1 microamp. So if this thing reads 50 millivolts, it's equivalent to 50 microamp sleep current. So we got the power supply set for 3.3. Let's turn that on. Give it a few seconds for it to stabilize. It looks like this card has 53.2 microamp sleep current. Okay, card 2 is a Toshiba 512 megabyte. We're going to say it pulls 66 milliamps. Card 3 is also another Toshiba 512 megabyte card. Call that 64. Card number 4 is a SanDisk 512 megabyte card. Definitely a big jump there. I've noticed this before. SanDisks like to bounce around a little bit. They take a while to settle. I prefer to take the initial number, which is about 92. Card number 5 is also another SanDisk 512 megabyte. Let's say 66 on that. Card 6 is a Samsung 512 megabyte. Whoa, big jump there. We're going to go 119 on that. Card 7 is a Lexar 1 gigabyte. Go with 91. Card 8 is another Lexar 1 gigabyte. That's amazing. Card 9 is a SanDisk 2 gigabyte. Go with 101. So now we've tested the first 9 cards, and usually you see 100 microamps or lower for a sleep current. And that was from 128 megabytes up to 2 gigabytes. Well, I threw this one in here for comparison for people who are data hungry. You need a lot of storage space. This is a PNY 16 gigabyte micro SD card. Let's see what this shows up. $730 microamps sleep current. Now, unfortunately, I only have one 16 gigabyte card to compare to, so this might not be indicative of all of them, but you have a big jump from 2 gig up to 16 gig. There's a ton more transistors in there that it has to keep charged or keep alive, so that translates into why my meter just went to sleep. But that's why it takes a lot of power in sleep mode on a bigger density card. So now we have all these numbers. Let's plug it into the database and see if we see any trends.
Okay, you'll have to excuse the microphone. I don't have the best external microphone for my computer. But here we go. Here's the database, starting with our 128 megabyte SanDisk card. Going 512s, I have 2 1 gigabytes, 1 2 gigabyte, and 1 16 gigabyte. And all the way over here on the right is our sleep currents that we just measured. Now you can tell basically everything from the 128 up to the 512, except for the last one, usually runs around the 50 to 60, except for this one SanDisk one that wanted to run at 92. They usually run below 100 microamp sleep currents. Now when it comes to this last 512 megabyte Samsung, this one has a different product name built into it. I don't know if that's indicative of maybe this is a fake, because that pulled 119 microamps. But if you look at the other 2 Samsung cards I have, one is a 1 gigabyte, the other one is a 2 gigabyte. The product name, they're the same, 00. So, and they pulled only 91 and 101. That's for the 2 gigabytes. So you expect a little bit more power draw. Now the question is, I need more Samsung cards to verify this. Is the 50s the fake cards that just pull less power? Or is the SMI Samsung card the fake card that pulls more power? I'm thinking more that this is the fake, although I haven't had any problems writing to it so far. I gotta do a write test to all these. What was really interesting was the 1 gigabyte Lexar card. Now remember, Lexar doesn't really make their own cards. They basically rebrand. That's why my first 1 gigabyte Lexar is branded Lexar, but it's actually built by Samsung. The second one is actually built by Baron Electronics. It's actually even newer too. 999 megabytes. Only 44 microamps. I would love to get my hands on a few more cards that are actually built by Baron and see if this is indicative of their way of making microSD cards. Are they more efficient? And PNY is also another rebadger basically, but they're legitimate. They're not Chinese clones and fakes and everything else. They're using a company called Gialec, if I pronounced that correctly. I like the fact that the product revision is 0.2. It's not even 1.0, so I have no clue what's up with that. But again, you're having a jump from 2 gigabytes to 16 gigabytes. So that is definitely why we went from 100 microamp sleep current to 730. There's just a ton more transistors in there. So if you need a lot of storage space, you better have a big battery. But if you're like me, where I'm only data logging 5 or 6 kilobytes a day, a 128 or 512 megabyte card will get you by perfectly fine for the whole time. But again, if I can find another card that only pulls 44 microamps, I'm definitely going to go for it.
So this is why it's a really good idea to test your micro SD card in some sort of rig setup like this to make sure that you get the lowest current but highest capacity card that you need for your Arduino, your Teensy, whatever you're using for data logging. Because believe it or not, a jump from 69 microamps to that Baron Electronics to 44 microamps, if you're data recording over a year, that could equal another week or two's worth of battery power available instead of being wasted in sleep current. Now, I'd love to test more cards. If anyone has any old micro SD cards sitting around or ones that they just want tested, go ahead onto my channel page. Make sure you're subscribed. Then click on the About tab. There'll be a button in the upper right hand corner. It says Send Message. Send me a message. This way we can have you mail your micro SD card in. Either you can donate it to me, which I'd be very grateful. I will test it. I will put it in the database. If I get enough cards, I'll make another video of it. If you do want the card back, we'll talk through email and we'll get return postage. I'll test it and then mail back to you and let you see what the results are. Thanks once again for watching. If you liked the video, thumbs up are always great. If you didn't like it, be honest, thumbs down. You ain't gonna hurt my feelings.